Hello guys, today I'm going to explain you about OLS and MLE. OLS and MLE are the two methods which we can use to calculate the parameter values of linear regression model, simple linear regression model, right? So these are the two methods, and I will also tell you when output of the data set follow follow normal distribution, then OLS and MLE give you the same result, right? I will tell you in the next video about the MLE and their how they are the same, right? And let's discuss about the first ordinary least square. Okay, so suppose we have these five data set, 5 points in a data sets, right? And this red line is a representation. This is an estimated value, and we don't know whether this red line is a baseline or not, which representing the data set or not. And we don't know, so can we assume this equation is a two representation of original data set, this overall all the data set, right? Two representation. Can we assume like this? And if we can assume, then this equation is a two representation, right? So I say this equation is one, and this is a equation two, right? And this formula is also called simple linear regression formula, right? So this is a which is a line or representation or a model of the data set, right? So and we want to know this estimated line and the two representation of the data set, how this estimated line is, how far and what is their difference between, how far from the actual difference, right? So if we want to find out how far it is from the actual representation, then we have to take the actual representation minus the estimated value, right? This formula tell you the difference or how of the actual representation of the data set and the estimated value, or we can say how far it is from the true representation, right? So this is called the error, also error or residuals, right? Residuals. So this is the first point I mentioned about it. This is the first point. Okay, and if we have 5 points and we take the difference, right? This five, the difference between the actual value and the predicted value, right? This is the difference, right? This give you some minus result and this give you positive result, right? The minus result and the positive result of the actual and the predicted values, right? Or estimated value. So if you take the summation of all these all the data, all the predicted and actual values, their difference, right? It give you some negative and positive value, and you do summation, right? So once you take the summation, the value could go positive, negative, or zero also. And we don't know what actually means. We know if we have a zero error, it means we don't have any error, right? And if it goes to minus, so how we say, like, what does it mean, right? And if it is goes positive, then we can say, okay, this that much error we have it, right? So that way, in order to remove this minus value, we had to take the square of their difference, right? The difference is the taking the difference, and this is called least square. Okay, this is the least square. And if we take the summation of all these predicted value, right? I is equals to from 1 to n yi, and this predicted value, the actual value and the difference, right? And the square of all these values, right? So this is called the sum of squared error, sum of squared error, called SSE, right? So this give you single value, right? Which is from 0 to some we can say like x or not x, that's an infinity value, right? Some infinity value. So if you get the very positive number, it means it contains a lot of error. If it goes towards zero, then it say we are reducing the error, right? We don't have much error in this side. So how we calculate the B and W value by using this formula, right? Because we want to minimize this function, sorry, third one, right? Minimizing this function means we want to reduce the error which goes towards zero, right? And so if we want to minimize, we should know the optimal value of B and W, right? These parameter value, right? So the overall goal of uh, calculating the error and come up with the best estimated value of B and W, right? By minimizing this function. So this is the overall goal, right? To estimate the best line which can fit the overall data set, right? Sorry, this fine should not come here. To estimate the best line and which can fit overall data set. This is our overall our goal, right? Let's go to the different slide, and before going to explain how to calculate the optimal value of BW, I want to tell you the some terminologies. Okay, explain the terminologies, right? So suppose we have a this is called, first let's discuss about the sum of square of x. What does it mean? So this x is a mean value of all x. So suppose if x is a feature which have like 1, 2 or 3 value, then we summation of these values 6 and divide by overall, because we have 3 data set, it give you 2 result. So this represent 2 as a mean value, and we take the all the x value which is from I and their diff x value minus with their mean value, right? And if we square them and divide by n, this is the variance of x. This is called variance of x, variance of x. This is the formula. So we represent this called var of x. Okay. And similarly for y, so all the actual value of y minus mean of all the value of y, we take the difference, uh, do the square of these difference, and that take the summation from I is equals to 1 to n, divide by over number of data sets, number of points in a data set. So it give you the variance of y. Okay. Similar, another point which I want to tell you about, sum or product of x and y. Okay. So we have like x bar, which is a mean, all the value of x, and y minus y I. So not this, I should not come here actually. This because we have only one value, right? This I should not come. Okay. So if we do the product of xi x bar and y minus y r, right? So suppose this x is called x. Suppose this one is called small x and this small y. Multiplication of this x and y, and the summation of all these values divide by n. This is called the covariance. Covariance. Covariance tell you how n and x both are related to each other. Okay. Now, as I explained earlier slide, I told you like how to calculate the best line. So how we calculate the best line? This is the overall goal, right? So we need to calculate the optimal value of B and W to get the best line, right? The B and W value, because we, right, the good optimal value means the best value, right? And how to get the new B and W value, right? So we have to have some kind of formula. So how to get the formula? By taking the derivative of SSC value. That is also called minimizing the SSC function, right? You know SSC function is, right? SSC function is the summation of I is equals to 1 to n y minus y hat squared, right? This is the function called SSE function, and we replace this y hat with estimated formula, which of simple linear regression is called b hat plus w hat xi, right? And then this, if I say this function is gx, and if we want to take the derivative of this function, we have to take the partial derivative function of b with respect to b of this function, right? So we get this result. By solving this further, we get the formula of b. I'm not going to tell you or explain you here how I got this result. You will get a lot of other videos and blogs which tell you how to take the derivatives with respect to b, right? So this is the final result you get, and from that you get the new value of b by calculating the mean value of y minus w and x. W is the previous value here, okay, or the new value you could say. And how to calculate the value of w, we have to take the partial derivative function of this function gx with respect to w. You get this result, and once you get this result you get the w value here. Once you get the w value, you fit this w value to here, and you will get the new value of b, right? This is the OLS methodology to calculate the B and W value. Okay, let me explain you this diagram here. So you know this is the mean value of Y and the mean value of X, right? Here also mean value of X and Y, right? So definitely this, if we get the B and W value, right, and this is the line we come up with, right? Y hat equals to b hat plus w hat x, right? So this line should go through the mean value of x and y variant, right? Mean value of x and y. This is the mean and xy. This one, okay. And because also in this formula we know how we calculating the b and w by using the mean value of y and x, right? So this line should go through the mean value of x and y in simple linear regression model, right? So yeah, this is the overall b and how to calculate the b and w value. As I explained you also earlier in this, like uh, this terminology, right? So if you see the first part, this is also called as pxy, this one, okay? And this denominator xi minus x bar overall square is also called ssx, right? So this also you can represent like the sum of product of x and y divided by ssx. Okay, okay. So yeah, okay guys, thank you very much. I will explain you MLE in the next video.